Hello friends, welcome you all again for studying the basics of pharmacokinetics. So now I will be discussing about the metabolism or biotransformation. The learning objectives are, so you will be able to describe various metabolic reactions and the phases of metabolism. You will be able to explain what is enzyme induction and what is enzyme inhibition. So we know that after absorption the drug comes into systemic circulation and then it is distributed, and after distribution and absorption the drug is available for action. So when its action is over, it has to be eliminated from the body, and for its elimination there are two processes. One is biotransformation and excretion. Biotransformation, that is metabolism, and both biotransformation or metabolism converts the drug from one form to another. Transformation means change and bio means this change occurs inside the body. So that means biotransformation converts one form of drug into another form so that it is excreted. Metabolism, meta means change and abolism means conversion. So both these terms, they are responsible, or both these processes, they are responsible for conversion of drug from one form to another so that it is excreted. So biotransformation is nothing but it is the chemical transformation of drug or alteration of drug inside the human body. The drugs are treated by the body as the foreign substances, that is they are xenobiotics, and therefore they are subjected to various mechanisms to get rid of these by the body, and that's why metabolism converts the drug into a form which facilitates their elimination. Most of the drugs, they are lipid soluble and non-ionizable and therefore reabsorbed from renal tubules and are not excreted. That means unless and until the drug is in lipid soluble or non-ionizable form, they are reabsorbed, they will not be excreted. So for their excretion, the drugs should be converted from one form to another, and metabolic processes converts lipid soluble drug into water soluble, that is it converts lipid soluble drug into lipid insoluble product which are easily eliminated either in urine or through bile. There are various sites in the body where metabolism occurs. The primary sites are liver and kidney. There are some other sites where the drugs are metabolized, including intestinal tract, skin, lungs, plasma. In liver, metabolic reaction takes place primarily in hepatic endoplasmic reticulum. So these are the sites of metabolism. By the process of metabolism, there are three possibilities. When the drug after metabolism, there will be three possibilities, that is inactivation, it may lead to inactivation of the drug. Metabolism may converts active drug, may forms the activation of metabolite from active drug, or it may lead to activation of inactive drug. That means in inactivation, conversion of active drug into inactive metabolite. In second case, there will be conversion of drug into one or more active metabolite, and the third case, inactive drug after metabolism gets converted into pharmacologically active substance, that is active metabolite will be formed. Example is morphine converted into codeine. Such drugs are called as prodrugs. Next is the various phases of metabolism, also called as the chemical reactions involved in the process of biotransformation. So basically there are two processes: phase 1 reactions called as non-synthetic, phase 2 reactions called as non-synthetic or conjugation reactions. Phase 1 into subclassified into oxidation, reduction, hydrolysis, cyclization and decyclization. Phase 2 reactions into conjugation, that is glucuronide conjugation, sulfate, glycine and glutathione conjugation, acetylation and methylation. Let's see these one by one. First is phase 1 reactions, that is non-synthetic reactions, also called as pre-conjugation reactions. So these reactions produce a chemical change in the drug molecule. So these reactions requires enzymes which are present in endoplasmic reticulum, that is called as the microsomes. So that's why these enzymes are called as the microsomal enzymes. Phase 1 reaction produces more water soluble and less active metabolite which are readily excreted. So there are various phase 1 reactions. The first one is oxidation. As we all know that Oxidation involves addition of oxygen, that is addition of negatively charged radical, or removal of hydrogen, that is removal of positively charged radical. These are the most important drug metabolizing reactions. Oxidation reactions are catalyzed by a group of enzymes called as microsomal enzymes. Example is mixed function oxidase enzyme systems, MFO enzyme systems, also called as monooxygenases, which comprises of several components such as P450 hemoprotein, NADPH, cytochrome P450, reductase, and oxygen. Examples of oxidation reactions are hydroxylation, wherein phenobarbital is converted into para-hydroxyphenobarbital, phenytoin into para-hydroxyphenytoin, N-dealkylation, codeine converted to morphine, imipramine into disimipramine, sulfoxidation, wherein chlorpromazine is converted into chlorpromazine sulfoxide. Another reactions are reduction, which occurs conversely to oxidation, and it also involves the same enzymes, but they work in opposite direction. The drugs which are primarily reduced by reduction are chloral hydrate, chloramphenicol, halothane, etc. Example is prontosil converted into sulfanilamide, chloral hydrate converted into trichloroethanol. Next is hydrolysis. So we know that lysis means breaking down with the help of water molecule. So this involves cleavage of drug molecule by taking up of water molecule. Enzymes involved, they are called as the esterases or amidases. Example is acetylcholine combines with water in presence of cholinesterase enzyme and forms choline and acetic acid. These reactions occurs in liver, intestine, plasma, and other tissues. Examples of drug hydrolyzed are cholinesterase, procaine, lidocaine, procainamide, oxytocin, pethidine. Another two reactions are very minor pathways, that is cyclization, wherein there takes place formation of ring structure from straight chain compound. Example is proguanyl. In decyclization, which leads to opening of ring structure of cyclic drug molecule. Example is phenytoin. So this is all about phase 1 reactions. Next is phase 2 reactions or synthetic reactions. So these reactions involves conjugation of drug, that is combination of drug or phase 1 metabolite, that means whatever is formed in phase 1 reactions, they combines with endogenous substance, endogenous substrate, that means which are already present in human body, maybe carbohydrate or amino acid or some other chemical groups, that is sulfate or acetate. Simply in phase 2 reactions, drug combines with the endogenous substrate, that may be carbohydrate, amino acids or chemical groups. End product form are more water soluble and they are eliminated in urine or in bile. The enzymes which are involved in conjugation reactions are called as transferases. These reactions have high energy requirements. The various phase 2 reactions are as follows. Glucuronide conjugation. So these are the conjugation reactions. Glucuronide, that is carbohydrate residue. Another conjugation reactions are sulfate, glycine and glutathione. These are all the amino acid residues. In glucuronide conjugation, there takes place conjugation of glucuronic acid with the drug molecule, and glucuronic acid is derived from glucose. Example is morphine combines with glucuronic acid to form morphine glucuronide. In acetylation, the drugs having amino and hydrogen residues, they undergo acetylation reaction. Drugs which are amines and phenols, they undergo methylation reaction. Drugs which are having phenolic compounds and steroids, they are undergo sulfate conjugation. The drugs which contains salicylate and other drugs having carboxylic acid residues, they are conjugated with glycine. And glutathione, it is the minor pathway. Example is ithacrenic acid undergoes the glutathione conjugation. So simply drug combines with either carbohydrate residues, some other chemical groups or amino acid residues, and they are converted and they are excreted by metabolic reactions. Next point is enzymes involved in the process of metabolism. Enzyme plays an important role in the process of metabolism, and there are two types of enzymes, microsomal and non-microsomal enzymes. Microsomal enzymes, they are located on smooth endoplasmic reticulum, primarily in liver, also in kidney, intestinal mucosa. Non-microsomal present in cytoplasm and mitochondria. Examples are cytochrome P450, monooxygenase. Examples of non-microsomal esterases, amidases. Microsomal enzymes catalyze most oxidation, reduction, hydrolysis, and glucuronide conjugation reactions, whereas non-microsomal catalyze oxidation, reduction, many hydrolytic reaction, all conjugation reactions. Microsomal enzymes are inducible, that is, they are stimulated. Non-microsomal enzymes, they are non-stimulated or they are non-inducible. Next, we'll discuss two important concepts, that is enzyme induction and enzyme inhibition. Enzyme induction means enzyme stimulation. So we all know that enzymes are involved in metabolism. So when the enzymes are stimulated, metabolic reactions will increase, and when the metabolic reactions will increase, there will be less drug available in the body, and that is, it will be more excreted. Let's see an example. Some drugs, also alcohol, smoking, insecticide, carcinogens, increases the synthesis of microsomal enzymes, and they induces the hepatic microsomal enzymes. As a result, the rate of metabolism of drug is increased. Drugs or chemicals which induce enzymes, they are called as enzyme inducers. Let's see here. Drug, when combines with enzyme inducers, it will stimulate the enzymes and it will increase the rate of metabolism. If the rate of metabolism is increased, there will be more drug available for elimination, and if the more drug is available for elimination, less will be available for action. There will be decreased action. There are some significance of enzyme induction, that is, if drug shows enzyme induction, proper adjustment of dose is required. There will be development of tolerance. Example is chronic alcohol consumption. Some enzymes are induced by alcohol which are responsible for cell metabolism of alcohol, and this is the reason why effects of alcohol are reduced after chronic consumption. It also leads to increased drug toxicity. Example is paracetamol. There will be some drug interactions wherein there may be failure of oral contraception and loss of anticoagulant activity. It can be also used for beneficial purpose in case of poisoning, to increase the rate of elimination of poisons by promoting metabolism. Enzyme inhibition. So some drugs inhibits the drug metabolized enzyme and reduces the drug metabolism. If the drug metabolism is reduced, it may result in exaggerated action of drug. Examples that are enzyme inhibitors are dicamerol, ketoconazole, cimetidine, sulfonamide. Here we see drug combines with inhibitor, it reduces the metabolism, and if metabolic enzymes are reduced, it leads to reduced elimination or inactivation, and it increases the intensity and duration of the drug. Exactly opposite to enzyme stimulation. Significance again includes proper adjustment of dose will be required. Enzyme inhibition may lead to increased drug toxicity. Example is dicamerol and phenytoin when they are taken together. So dicamerol inhibits the enzymes that are involved in metabolism of phenytoin. So if metabolism of phenytoin is inhibited, so more phenytoin will be available and there will be enhanced phenytoin toxicity. And there is another example of disulfiram-metronidazole along with alcohol. Many drugs are known to produce their effect through enzyme inhibition. So simply, enzyme stimulation leads to decreased effect of drug and enzyme inhibition leads to increased effect of drug. Opposite, enzyme stimulation decreases the effect of drug, enzyme inhibition increases the effect of drug. Increases the effect means toxicity. So this is all about the various processes of metabolism. Phase 1 metabolism, phase 2 metabolic reactions, various sites of metabolism primarily in liver and kidney, various enzymes involved in metabolism, microsomal, non-microsomal, and last two important concept, that is enzyme stimulation and enzyme inhibition. So thank you once again.